Hello everyone, welcome back to Xcoding with Alvin. In this video, I'm going to discuss about using the new Swift 5.5 Async Await to fetch REST API. As a nice developer, most probably you already have a lot of experiences writing code to fetch REST API from multiple endpoints. In some instances, the call to the API endpoints need to be in sequential order as they need the response from the previous API call to be passed in the HTTP request. Let me give you an illustration for such scenario with these given steps. Let's say we are given a task to fetch 3 REST API endpoints. First, we need to fetch the IP address of the user from the IP5 API. Then, using the IP address from the response, we're going to fetch the IP geolocation data from FreeGeoIP. The response contains the country code that we are going to use to fetch the country detail from the restcountries.eu API. If the final code we ended up writing will have 3 callbacks that are nested like this picture, then welcome to Pyramid of Doom, aka callback hell. The code is not easily readable, complicated, and harder to maintain as the code base grows. Let's say we need to use the country detail response to fetch another API. We will add the fourth callback, making the nesting become even much deeper. The Pyramid of Doom callback problem has already been raised as one of the most requested issues that the Swift language should eliminate. At 2017, Chris Latner, the creator of Swift, had even written the Swift Concurrency Manifesto, discussing his visions and goals to handle concurrency with imperative code using async await. Finally, with the accepted Swift Evolution Proposal 296, async await has been implemented in Swift 5.5. It is currently still in development as this video is created. The proposal provides the motivation to tackle 5 main problems. First, Pyramid of Doom. Second, provide better error handling. Third, provide better conditional execution of async function. Fourth, eliminate the situation where we forgot or incorrectly call the completion callback. And last, eliminating the design and performance issue of synchronous API because of callback API awkwardness. Async await provides the mechanism for us to run async and concurrent functions in sequential way. This will help us to eliminate Pyramid of Doom callback hell and making our code easier to read, maintain, and scale. Take a look at this picture, showing how simple and elegant async await code is compared to using callback. Let me give you the outline of what we will learn and build in this video. We will be learning and experimenting using Swift async await to solve 2 real-life tasks. First, fetch dependent multiple remote APIs sequentially. In this case, we are going to fetch IP address from IP5, geolocation from FreeGeoIP, and country details from restcountries.eu. Second, concurrently fetch multiple remote APIs in parallel. In this case, we are going to use Swappy to fetch Revenge of the Sith movie data containing the URL of the characters. Using these URLs, we'll fetch all the characters' data in parallel. Along the way, we're going to learn 2 main topics related to the Swift async await. First, task-based API introduced in Structured Concurrency Proposal 304 as the basic unit of concurrency in async function. We'll be learning on how to create a single task and task graph async functions. Second, interfacing current synchronous code with completion handler callback to async tasks using continuation API introduced in SE300. We'll be interfacing current URL session data task callback basic API to async await function. As Swift 5.5 is currently in development as this video is created, I'm going to use Xcode 12.5 using the Swift nightly development snapshot from swift.org. There may be an API change that break the current code when the stable Swift 5.5 is released in the future. Alright, now let's begin the project. First, you need to download Swift 5.5 development snapshot from swift.org. Make sure to select the Xcode one to download, then install the package into your Mac. After that, open Xcode and then from the menu bar, select Toolchains and select Swift 5.5 development snapshot. Okay, then as you can see here, now Xcode use this Swift.5 development snapshot. Okay, next you need to download the GitHub project repository. I provided the repository link at the description below. So just please go to the website and then clone or download the repo to your machine. Okay, now let's open the starter project in Xcode. Double click on this folder, select starter, and click on async api.xcode project to open in Xcode. Okay, so this is the project. As the current Swift.5.5 development build doesn't support building a Cocoa-based app, so we cannot build a app with user interface. So in this instance, I'm using a Mac console-based app for this project. And then for this project to run, I've modified several Swift flags. You can see inside the package.swift here, there are three flags that I modify here. First is parse as library. So this will eliminate the build error when declaring the async main function. So we can invoke async function in main. Second, enable the experimental concurrency. So this flag will enable the async await to be used in our project. And the last one is disable availability checking. This will eliminate build error of macOS 999 availability when building the project. Okay, let me show you all the models now. You can just click on this model folder. It provides two folders. One is for the SWAPy and the other one is for GeoIP. For the GeoIP, as we are going to fetch from multiple endpoints, three endpoints, we have the IP file response.swift, pre-GeoIP response.swift, rescountries.eu response, and from the SWAPy, we have the SWAPy response, the film, and the people. All of the models already conforms to decodable, so it should be easy for us to just convert this to the struct. Inside, you can also find all the URL that we are going to use when fetching the data here. You can take a look inside the starter project to learn more about these models if you are interested. It is a pretty simple model. Inside the fetch API task.swift, I just provide a global function that uses the URLSession share data task to fetch the URL and then provide the decodable data. It uses generic to convert the data to the correct struct. Just take a look here if you are interested. It's pretty simple. Last one here is the main.swift. This is the entry point of our app here. I declare this struct app with main keyword. So this will be the entry point of the app. This is introduced in Swift 5.3. Here we just need to declare a static main func here. This will be executed when we run the app. And inside here, first I fetch the API from the IP5 API and then convert it using the IP response here. After I get the response, here I just fetch the API from the FreeGeo IP, passing the IP address from the IPv response. And at last, I fetch the API from the REST country's response, passing the country code from the FreeGeo IP response here. This is the code. And here, as this main function will be executed synchronously, I'll use this run loop.main run until this done feature. So our app doesn't automatically exit when our code execute past this line. It will just keep running, and then this all of this call will be executed. So now let's just try to build and run. Let's see here. Okay, now let's see at the console here. Okay, this is the first one from the IPv response containing the IP address, and from the second API call, this is the free geo IP response containing the country code, and the final API call from the REST country's response. Here we get the country details from for Indonesia. Okay, so that's it basically for the starter project. Now we are going to convert this code to use asynchronous function. So as you can see, this is a parameter of Doom. It's very hard to read this code and also very hard to maintain, right? There are a lot of branches right here for handling error. You can see for this one, and this one. Okay, so let's begin our first task. Let's move on to our first task, which is to create our own async function using the all-new task-based API. So the async await proposal itself doesn't introduce the mechanism to handle concurrency. There's another proposal called structured concurrency SA304, which enables the concurrent execution of asynchronous code using the task-based API for better efficiency and predictability. I'm not going to provide a deep dive explanation about the structured concurrency proposal. I believe you will learn much better if you just read the proposal by your own self. And I have provided the link to the proposal at the description below. I'm just going to provide a practical example of how we're going to use the task-based API. So, okay, now how are we going to use this task-based API? Let me maximize this, make this a bit bigger. And then let's just try to see the public interface here, task. Okay, first let's just find the initializer. Okay, there are two initializer as you can see here. It needs this optional task priority to be passed and this mandatory operation containing the closures and the return type. One of them is a can throws. Okay, so let's see what is this task priority. So okay, so this is basically an enum. It has background, default, high, low, user initiated utility. I think this is similar compared to the dispatch queue quality of service, but it's not exactly the same as there is no user interactive here. But it might be this is just the development build. Okay, let's try now to create our first async function using that task initializer. Go to the fetch API task.swift and let's declare another function, fetch API. It's going to also use generic that converts to decodable. It has single parameter URL, and we don't need to pass the callback. And here, to make this as an async function, after the parameter declaration, we need to add this async keyword. Okay, and for the return type, it's going to be this decodable. And also I want to match this async function to be throwable. So let's also declare this throws. Okay. Now let's declare the task using the initializer. Uh, I don't need to pass the priority, I think, and it will use the current system priority. So let's just use the trailing closure here for the operation. It has no parameter, and the return type is going to be the decodable. Okay. Now let's fetch the data. How are we going to do it? I think the most simple way is just using the data contents of URL initializer. It's not really recommended as there is blocking and synchronous, not very good for performance. But as this task is going to be executed on the different thread, I think this is okay for this first task. Okay, it's not going to be executed in the main thread. Okay, let's declare data and then use data contents of URL. Make sure to proceed it with try as it can be thrown. And then let's decode the data using JSON decoder. Decode to the type of D and from the data. And finally, just return this. Okay, this is the task. Okay, this also can throw. And how do we get the data from the task? We can use this. There's this value. So when we use this value, this is basically an property that is also async. It will wait for the task to complete, returning or throwing its result. Okay, let's use this. And as this is an async property, we also need to use await here. So whenever we want to get the result from the async function or property, we need to use await. And this await can only be executed inside an async context, as you can see here. Okay, let's just return this. And as this task can throw, let's use try keyword here. Okay, return try await task.value. This is it for our first async function to fetch the URL and get the model. Now let's put this function into action. Let's go to main.swift. Okay, as you can see here, our main function is a synchronous function, and we won't be able to use await keyword and call our async function. So basically, we can convert this into an async main function just by adding this async keyword after the parameter. And then let's just delete all of this parameter of doom callback code. And then let's use our async function. Okay, first let's fetch the IP file to get the IP address, and then assign it to this IP response let. The type will be IP response fetch API, this one, async one. To get the API, just use this IP response.url to get the static constant. Okay. So first, as this can throw, let's wrap it in a do try catch. Let's move it. And for the when it throws an error, we just print an error, the localhost description. And let's print the response. Oh, we also make sure need to use try await here. Okay. Next, we're going to use the data from the IP response to fetch the free geo IP response. The type will be free geo API response. Let's use try await fetch API free geo API response dot URL. This is a static method. And then let's pass the IP address from IPv response. Okay. Then print the free geo IP response. Next, Let's get the REST countries response using try wait, fetch API. Okay, REST countries API response is a static method URL. Let's pass the country code from the IPv response, from free geo IP response. Okay, and then let's train it. Okay, that's it for our async function. Now let's try to build and run. Let's see the result. Okay, looks good. First, we get the IPv response containing the IP address. Then we get the free geo IP response containing the country code. And finally, using the country code, we fetch the country details from the REST countries. And then we got the country details for Indonesia. That's it for our first task. But before I wrap up this task, I want to show you one way that you can use to call an async function inside a synchronous function. Okay, now let's just say this is a synchronous function. Remove the async keyword. Now, as you can see, it will give an error, right? Because it need to be called in a async context, and this is not an async function. So how do we call this? We can use this detach. So basically, with this detach, we can just pass a closure, and that closure will be executed in an async context. Okay, this will be executed concurrently. So we need to use that run log.main run until just run it into an indefinite time in the future. So let's try this, executing this inside the main synchronous function. Okay, we still get all the response. This is one of the way. This is just like fire and forget. That's it for our first task. Okay, now let's move on to the second task, which is to fetch multiple REST API in parallel. For this example, I'm going to fetch data from Star Wars API, data for the Revenge of the Sith. As you can see here, it contains an array of string for the characters. This is basically an URL. I have provided a computed property to transform this array of string into an array of URL, and we need to fetch them in parallel. We don't want to fetch them in sequentially, right? It will be a waste of performance, especially if we have machine with a lot of cores and threads, such as MacBook Pro 16 or maybe M1 MacBook Pro or MacBook Air. We want to achieve the best performance, right? So luckily, the structured concurrency proposal provide a API for us to achieve this. We can use the task group they call. With this, we should be able to execute group of async functions in parallel. Using this task group, we can spawn new async child tasks within the async scope and closure. And we also need to make sure to complete all the child tasks inside the scope before it exits. So without further ado and explanation, let's just see how can we implement this. Now let's go to the fetch API task.swift here, and then let's declare a global function. Let's give it a name of fetch API group, and we also use it will be a generic function with a decodable type. And for the parameter, we're going to pass array of URL, and it's going to be async throws. And for the return type, it will be array of decodable. So how can we initialize a task group? For that, we can use the global function with task group, and there are several functions here. And for our example, as this is an async function that can throws, we're going to use the with throwing task group. For the child task result type, it will be the generic type. And let's provide a closure here to perform the child, to spawn the new child task. And let's just loop the URL, and in each loop we're going to spawn a new child task using this group.async. We don't need the priority, just use the default priority. And for the task here, I'm just going to just copy this all of this method to fetch the URL and then decode the data. Okay. Later we're going to convert this to URLSession. Okay. So we have to do this. Now we still need to call await for all of these child tasks, right? Let's just declare an array now with the type of array of D to store the results. And let's use this new async sequence, which is another proposal called async sequence proposal number 298 that we can use to iterate this async sequence. Group itself is a async sequence. As you can see, async iterator provide this next, and this next is also async, right? So for that, we can use for try await. It can be throwing, right? It can be, let's name it result in group. Okay, this will iterate all the group, and whatever the child task that comes first will be appended to the results array. That's it. If you want to learn more about the async sequence proposal, I have provided the link at this description below if you want to learn more about it in detail. Okay. Call can throw, but it's not more than try. Okay. So this is also an async function, right? We need to use try await. Okay. Let's try to build and run first. Okay. Now build succeeded. Now let's go back to the main.swift. Let's extract this into another function. Let's give it a name of fetch GOIP data. This is an async function. Okay, and then inside our main, let's give it async keyword. Now let's fetch data from the swappy. Let me just declare this. First, we're going to fetch revenge of the Sith data. And it will be type of swipe response. This is a generic struct, and the type will be filling. Okay, and it's going to use this one. This is just a single API. This one, and when we use, you are passing the ID. For the ID, I already find the ID of range of the seed is 6. So let's just pass 6 here. And let's mark this with try await. Okay. Let's just print response. Range of this is data.response. And now let's fetch the characters. As there are many characters, I just want to fetch the first 3 characters. So to do that, I'm going to use the fetch of this shift data.response. This is the film struct, and let's access the character URLs and then use this prefix. Going to up to 3. Okay. Now we have the first 3 characters. Let's fetch it in parallel. Let's give a character response, and the return type will be array of swipey response film, not film, sorry, it's going to be people. And let's use try await fetch API group, passing the URL array characters. Okay, Okay, now just let's convert this to array first. Okay, now let's print the character response and see the results. Now let's try to build and run for the moment of truth. Nice. Now, okay. First, we got the reference of this Sith response here. It contains the metadata for reference of the Sith, as well as the array of string containing all the characters URL. And then after that, we fetch the characters, the first characters using this. And as you can see, the response is printed in the console successfully. Nice. Now, so we have completed the second task, which is to fetch multiple APIs, multiple tasks in parallel using the TaskGroup API. One more thing that I want to mention about this task group is here. As you can see, we use this withdrawing task group, right? So basically, if one of the child tasks failed here, right, the task itself will be canceled and we won't be able to get the data. And in our case, it will throw an error, right? So if you want one of the child to be failed gracefully, you can use this with throwing, sorry, with task group, right? And maybe for the type, we just make it an optional, right? If you want. So with that, if one of the child tasks fail, it won't make the overall task fail. That is just one the thing that I want to mention about using the task group. Now, let's move on to our final task, which is to use the continuation API. So what exactly is the continuation API? I think this API is one of the most super important API for the async await. As with this continuation API, we will be able to interface our current synchronous code with callback to async function. So for this video, I'm going to convert URLSession data task as an async function. To do that, let's just declare a new file, give it a name of URLSession plus async. We're going to implement this as an extension of URLSession. And let's declare the method func data with URL. It's a single parameter. And it's going to be a throwing async function. Let's use this async throws with the return type of data. I want to code the data to the model, so it just returns the data. So how do we access the continuation? We can use with continuation here. There are several one, throwing and non-throwing, and also save, unsave, or uncheck. In this video, I'm going to use this with check throwing continuation, and then in the closure, it will pass this continuation. So what exactly we are going to do here with continuation API? Basically, we need to exactly call resume once here, whether it's returning data or it's throwing the error. We need to make sure to call this once. If we call it twice, it will make an undefined behavior for the system. And for the check throwing continuation, whenever we call this twice, the system will crash. This has a performance cost at runtime. So Apple also provide this with unsafe continuation if we want to use it. If we use the unsafe one, we can call resume multiple times, but the system won't throw an error, and maybe it will create an undefined behavior for our system. And for our purpose here, we're going just to use the check one. Okay, I think it's more safe and it's more better to use in production, right? And let's just make this try away to remove the error. So inside this closure, we're just going to use data task, the URLSession data task. passing the URL. This is the completion handler, data response error, the plain old data task. Here I'm going to just handle this simply, right? I won't check the HTTP response status code or anything else. But you should handle all the error gracefully in your production code. Okay, now let's just first check the error. If the error exists, I'm going to invoke continuation resume, throwing the error, and let's check whether the data exists or not. Okay, if it is exists, I'm going to use resume, returning the data. And finally, in the else clause, I'm just going to throw an error and with the custom NS error. Just with random code, just say bad response. So this is it. Let's try to build and run. Okay, the build succeeded. Now our URLSession data task has a async function to fetch a data with a given URL. Now let's go to the previous fetch API task.swift file. Let's convert this data container URL to use that URLSession async function. I'm going to create a helper function here to just fetch and decode the decodable. The parameter is URL, so async throws, string type is D, and inside here I'm going to use the URLSession. In this case, I'm going to the shared instance and use the new data with URL async function to fetch the data. Pass the URL and get the data, and then let's just call try with JSON decoder, decode the data using the generic B, and finally return the decoded data. Okay. Now we can use this helper function inside here. So basically, I don't need to use the task anymore right here. I can just, what's this? Operational. Okay, sorry. This is not an wait, a nesting function. Okay. I don't need the task anymore as this is already an nesting function. So basically, I can just remove this and call fetch and the code passing the URL. And here I can also call fetch and the code passing the URL. Okay, let's use try, wait. Okay, the build is successful. Now let's try to use this. Okay, oh, I think I forgot something, which is I think I need to call resume on the data task. Let's go back here. Otherwise, the task won't be started. Now let's try to build and run. Okay, still working as expected. Turns the film and all the characters for the film. That's it for this video. As Async Await itself is a pretty big API with so many features, I won't be able to cover everything in a single video. So please also read the proposal and learn them by yourselves. There are many things that I haven't covered in this video, such as task cancellation, task yield, async lead binding, and many more. Okay, and before I close this video, I want to give my own points for the async await API. First, I think async await helps us to manage the code complexity and complication when using many functions with callback, as well as providing a simpler control flow and better error handling. It's very useful for UI and server domain, where everything should be asynchronous and non-blocking. I think Combine is an alternative approach for managing asynchronous flow using streams in a reactive way with publishers and subscribers. It is a closed source framework by Apple, not built into Swift, so it can only be used in Apple platforms. It cannot be used in Linux or Windows. It is such an amazing time to be part of the Swift developers community and build wonderful things around the world to solve the complex, challenging problems using technology. So let's keep on becoming a lifetime learner and coder. Bye.